Hello. In this video I'm going to explain polarization. Now remember, light is an electromagnetic wave and it's a transverse wave, which means if you have light propagating in this direction, you have an electric field that is oscillating in a direction perpendicular to the direction of travel. Now if you have a beam of light coming towards you, then the electric field could be oscillating horizontally this way, or it could be oscillating vertically this way, or it could be oscillating diagonally this way. In fact, in a beam of unpolarized light, the electric field is oscillating in all possible directions. Now there's such a thing called a polarizer, and a polarizer has what's called a polarizing angle. What a polarizer does is that it allows only electric field, which is oscillating in the same angle as its polarization angle, to pass through. Which is why we can polarize and unpolarize light by passing it through a polarizer. So for example, we start off with an unpolarized light and we pass it through this polarizer, which has a vertical polarization angle. After passing through the polarizer, we have a beam of polarized light, because in this beam of light we have only E field that's oscillating vertically and in no other direction. Now things become really interesting when we try to pass a polarized light through yet another polarizer. Now clearly, if the light is polarized parallel to the polarizer, then the entire beam of light will pass through. It's as if the polarizer is transparent to the beam of light. On the other hand, if the light is polarized perpendicular to the polarizer, then nothing can pass through. On this side of the polarizer, you get nothing. So it's as if the polarizer is totally opaque to the beam of light. What if the polarizer is neither parallel nor perpendicular to the light? For example, the polarizer could be like this. Let's say it's at an angle theta to the vertical. So the situation looks like this. We have a beam of polarized light with an oscillating E field of amplitude, let's call it E0. And it runs into a polarizer which is misaligned by an angle of theta. So what's going to happen to this beam of polarized light? Now we're going to use the very useful trick of resolving vectors again. So this E field can always be resolved into two components, one that's parallel to the polarizer and the other that's perpendicular to it. So the one that's parallel to it will look like this, and the one that's perpendicular to it will look like this. So the parallel component will be E0 cosine theta. See this right angle triangle here? And the components that's perpendicular to the polarizer will be E0 sine theta. This component will totally pass through the polarizer since it's parallel to the polarizer, whereas this component will be totally absorbed by the polarizer since it's perpendicular to the polarizer. So what happens after passing through the polarizer is, first, the polarization angle of this beam of light will change. It will change to a new angle that's aligned with the polarizer. That's the first thing. The second thing is, its amplitude also gets reduced. Before the polarizer, it was E0. After the polarizer, it will be reduced to be E0 cosine theta. What about the intensity? Now remember, intensity is proportional to amplitude square. So if before the polarizer the intensity was I0, then after the polarizer, the intensity would have become I naught cosine square theta. And this is known as Mailer's law. Okay, let me do a quick demonstration using real polarizers. This is a light pad. Let me switch on the light. The light that's coming towards you is unpolarized light. So let me drop one polarizer here. So now you get polarized light. So now let me pass the polarized light through a second piece of polarizer. If these two polarizers are parallel to each other, then all the light passes through. But if I turn it 90 degrees, then the two polarizers are now perpendicular to each other, and you see no light passes through. I turn it another 90 degrees, all the lights gets passed through. Another 90 degrees, and it gets cut off again. Alright? So that's all. Ta-ta!